Hi, let us talk about circular doubly linked list. In circular doubly linked list, every node has two pointers or references like a normal doubly linked list. The two pointers or references are previous and next. In normal doubly linked list, previous of first node is null and next of last node is also null. But in circular doubly linked list, previous of first node is last node and next of last node is first node. And that is why we call it circular doubly linked list. Here is an example of empty circular doubly linked list. Like other linked lists, we represent empty circular doubly linked list as null. A single node circular doubly linked list, a circular doubly linked list which has only one node, looks like this. This node is head, its previous is itself, its next is also itself. That is how we represent a single node circular doubly linked list. Let us now see advantages of circular doubly linked list. Since it is circular and doubly, we get all advantages of circular linked list and all advantages of doubly linked list. An example advantage of circular linked list is you can traverse in circular way. If you are at the last node, you can come back to the first node. This can be useful in implementing problems like round robin algorithm or implementing the problem like Josephus problem. So we get all the advantage of circular linked list, and advantage of doubly linked list are you can delete a node before a node in constant time. You can insert a node before a node in constant time. You can traverse back. If you are at a node, you can go back and see all the previous nodes of it one by one. Now with circular doubly linked list setup, we get one additional advantage. We can get the last node in constant time without maintaining extra tail pointer. Since our head's previous is last node and we have head pointer or reference, we can get the last node by simply doing head arrow previous or head dot previous, which is a constant time operation. And this makes many operations simpler in a circular doubly linked list. You can insert at the end in a quick manner because you have access to the last node. You can delete from end also in a quick manner because you have access to the last node, and using the previous pointer or reference of the last node, you can get the previous of the last node and you can delete the last node easily. So you get multiple advantages with this setup. Talking about traversal of a circular doubly linked list, since it is a circular linked list, we can't traverse this by putting a loop termination condition saying while current is not equal to null, right? Because current never becomes null. So to traverse a circular doubly linked list, we need to write the same code that we discussed in a circular linked list. We talked about different methods of circular linked list traversal. We can use those methods here in a circular doubly linked list as well. Let us now talk about insert at the beginning of circular doubly linked list. So we are given a circular doubly linked list and we want to insert a node at the beginning. Suppose I want to insert a node 5. So 5 will come here, it will become new head, and next of 30 will become 5, and 5's next will become 10, and 5's previous will become 30. So please pause this video now and try to write down a function that takes a data x as an argument, head of the circular doubly linked list as an argument, inserts the data at the beginning of the given linked list, and returns the new head. Here are C++ and Java implementations of insert at head of a circular doubly linked list. So the first thing that we do to insert is we allocate memory for a node. This is what we have done as a first line in both the implementations. After we allocate the memory, we need to decide what are going to be the previous and next of this temp memory that we have allocated. So previous of this 5 is going to be this 30. And next of this 5 is going to be 10. So we know previous of temp is going to be head's previous. So we have done temp previous equal to head previous, right? And then we have done temp next equal to head. Temp next equal to head. So what does it mean? We have changed temp next equal to head and we have changed temp previous equal to this node, right? Now we need to change these links also. Next of this should be 5 and previous of this should be 5, right? Right now previous of 10 is 30 and next of 30 is 10. So that is what we do as a part of next two lines. So in the next line, we do had previous next equal to temp. So we want to change the next of this. We can access this using had previous. So we get had previous, we get access to this, and then we change the next of this to 5. So we change this link. So we change this link from here to this node. And after that, we change had previous to temp. So currently had previous is this 30 node. We are changing it to 5. After we change it to 5, we return our temp as new head, right? So we've executed all these lines, right? And now we are going to return this node as our new head. So our head changes to this thing. So this is how we insert at the beginning of a circular doubly linked list. Now please pause this video and think, how will you insert at the end of a circular doubly linked list? Please note that inserting at the end of a circular doubly linked list is going to be similar to inserting at the beginning of a circular doubly linked list. What all we need to do is we need to insert the same way. We just don't want to change the head. That's all, right? If head was here, we want to keep the head here, and we want to just insert at the beginning and then don't change the head, which is effectively insert at the end, right? So if I do all these steps and if I don't change the head, right, it means I have inserted at the end, right? This is after the head node. So inserting at the end is just don't return the temp, return the same head, right? Now talking about this corner case, if our head is null, then we just want to create a single node with previous and next referring to or pointing to itself. We must handle this case separately, because if we go and access null arrow previous or null arrow anything, we'll get segmentation fault in C++ and null pointer exception in Java. So that is why we handle this particular case explicitly. So in this video, we have introduced circular doubly linked list. We have also talked about its advantages and insertion operations.